Hey guys, Mr. Gallen here, starting a new week. And so we have some new problems that have been posted on Quizzes. Several of you have already done this lesson, and that's okay. Working ahead a little bit, but many of you might need a little bit of assistance. I would recommend trying to do this lesson without the calculator to prove that you understand how this works. Number lines can be helpful if you get stuck. Just start at the first number, like for this first problem here at -2. If you start there, if you go there first, and then do the action of what it says next, take away -8. Now that might be hard to determine. Okay, what direction are they talking about going 8 steps? The left or the right? -8 makes me think left, but then there's a minus in front of it, so that affects it, right? One thing that we talked about, and this is huge, and you use it in algebra. We've used it a bunch in algebra too. Uh, is taking a subtraction problem and converting it to its addition equivalent. So if you take -2 minus -8 and you make it -2 plus, that -8 becomes its opposite. We add the second number's opposite, so it looks like this. So taking away -8 is like losing $8 of debt. And so if you take away debt, that's like increasing your value. It's the way that I think about it. So if I go up 8, where does that land me at? Well, it lands me at 2 to get to 0, and then 6 more to get where that ends up. So that would land me at +6. All right. And the way that we think about these problems is when we're adding, and I'll write this at the top, and this might not be a bad thing to remember. When you're adding integers, we have two rules. Number one, if the signs are the same, all right. So if this was a -2 and a -8, then we would add the absolute values. And then number two, if the signs are different, like they are right here, we have the signs that are different, a negative and a positive, then we subtract. We subtract their absolute values. You think of 8 minus 2, which gives us our 6. And then I guess you just always need to, the greater absolute value will always win the sign. So who has greater absolute value here, 8 or -2? Who's further from 0, -2 or over here at 8? 8 is. So it wins the sign, which is why it's a +6. So that first one would be +6. Easy to miss those if you're going through it really fast and you don't truly understand what's going on. All right. So from now on, let's do those rules. Okay. So if we add the opposite here, 0 plus -16, we clearly see different signs. Doesn't really matter with 0. When you subtract 16 and 0, you get 16. And then who wins the battle here? Well, clearly the negatives are going to win. You're going back 16 from 0. So if you think about the number line of it, if you're at 0 and you go back 16, you're going to end up at -16. So that one would be C. Number 3, if you add the opposite on that one, you're going to get 18 plus a +4. Okay, this is the same thing as just write 18 plus 4, which we all know is 22. So that one would be C. Number 4, no need to add the opposite because it's already a plus. I see a lot of students trying to add the opposite when it's already plus. Only add the opposite when it's a minus problem. If it's a plus problem, you're good to follow your rules. Signs are different. So we're technically going to be subtracting here to get our answer of 6, and then we look at the signs. Who wins? Does the negative win or does the positive? Well, the -10 has more absolute value, so this is -6, which would be C. And then lastly, on this first page, the signs are the same. There's already a plus. The signs are the same. So we're going to add their absolute values and get 31. And who wins the sign here? Well, they're both on the same team, so it's obviously going to be negative. So this would be -31. -31. All right, so that drops out the first 5 problems. Let's look at the next 5 or 6. I can't remember how many are on the second page. There might be more than 5. But let's go to number 6. Here we go. Let me pan this out just to give me some more space to write. And here we go. Signs are different here, so we want to subtract. So we're going to do 12 minus 9. No need to add the opposite there. 12 minus 9 is 3. And negatives with the absolute value. So that one would be negative 3. We should be getting faster at this. And then on number 7, it starts to transition over into you multiplying and dividing. So there's new rules for that. So let's write those down. So if you're multiplying and dividing, so this is for multiplication or division. Okay, different rules. All right. So in this case, if the signs are the same, right? If the signs are the same, like if you have two positives or two negatives being multiplied or divided, then you're going to get a positive outcome. And then if the signs are different, like one's negative and one's positive, like we see in this first problem here, then you're going to get a negative outcome. The signs have no bearing on what you do with the numbers. You're going to multiply or divide them either way. The signs have a bearing on what sign it's going to be. So think of it as having 4 negative 7s. And we did this when we did this unit. It was on the number line. If I have 1 negative 7, I'm right here. If I have 2 negative 7s, I'm right here. Right? I'm kind of skip counting backwards by negative 7. So if I have 3 negative 7s, I'm here. And this problem is I've got 4 negative 7s. So that puts me at negative 28. So that's why we have rules like this, is because this is what's happening. You're skip counting left or you're skip counting right for multiplication. And so 4 negative 7s puts me at negative 28. So that one would be C. All right. Number 8, the signs are the same. Negative times a negative. So we're still just going to do 8 times 5, as we always would do, and get 40. And since the signs are the same, it will be positive. So it would be D. And then the little slash mark just means division. So here you're thinking, okay, how many times will 27 go into itself? And that's once. And since the signs are the same, it's going to be positive. So positive 1. That would be C on number 9. Number 10, that one, we're multiplying again. The signs are different, positive times a negative. So we're going to get a negative outcome. We just have to do 12 times 4, which is 48. And since the signs are different, we get negative 48. So that one will be D. And then it just kind of tests these general rules on some of these questions. A negative times a negative will be a positive. All right. Negative 6 times positive 7. Put that there. Negative 6 times 5. The signs are different, so we're still going to do just 6 times 7, which is always 42. Sorry about that. 42. And since the signs are different, it would be negative. All right. So you move pretty quick after you have those rules down, and that's the idea. I don't want you to have to draw a number line every time that you see a different integer problem or a different negative problem. You should get those rules down pat. That way you can either visualize the number line in your head in which direction you should be going, or you just have the rules memorized and you don't make those mistakes. All right, so now it throws us back into addition again. So it's jumping back and forth just to make sure you understand the rules. Okay, the signs are different here, but once again, it's plus, not times. So we want to subtract. And 9 minus 9 is 0. So those are additive inverses. We talked about those too. C. And then on number 14, negative 2 plus 10, the signs are different. So we want to subtract. And we know that 10 minus 2 is 8. And the positives win the absolute value battle there. So that one would be A. And then the very last one is the signs are the same. So since the signs are the same, we're actually going to add their absolute values and take the sign of the one who's greater in absolute value. So this one will be negative 9. And that's it, guys. That's just a quick go over of the absolute value and integer work and operations with negatives. So, if you're still having trouble with that, you can always resort to using a calculator. But the idea here is to be able to do those mentally. It's going to make your world a lot faster. And when you get to algebra, you don't have to type every little calculation into the calculator. So that's all that I have for today. If you need more help on some of these problems or you want more practice, just email me. Let me know. I can shoot you some more resources, some more websites, some more practice problems. So hope you guys are well, and I will see you on here tomorrow as we go to the next lesson, which I believe is starting to solve some equations.